right, hey guys, we're going to move on. Section 7.5, the last section in this chapter that we are going to cover, and it's applications of vectors. So all the things that we've learned about vectors, we're going to apply them to real life problems. Okay, so we're going to begin with some terminology. We know that if you have two vectors and we add them together, we get a resultant vector. So we have a vector A, we have a vector B. When we add them together, we get the resultant vector. Okay? And that is A plus B. Okay? So today we're going to talk about the force, because all this is about force, the force of this resultant vector. But now we're going to talk about something that's going to counteract that resultant vector, meaning what's going to keep it stable. Really, what is the negative of the resultant vector? We're going to call that the equilibriant. Okay. It will also be known as the opposite of the resultant vector. Okay? They will have the exact same magnitude. And opposite direction. When I see this, I think about a seesaw. And a seesaw, the two people on each end are the exact same force, pounds, whatever you want to call it, that keeps this seesaw perfectly level. Okay, I've got my arm out like you can see me, you can't. It's going to make this seesaw perfectly level. Okay, meaning the force on this side will be equal to the force on this side. So it's level. Okay, so if we want to know what would make it equal, what would the equilibriant be? Okay, we can find the resultant vector and take the opposite of it. If we just want to find the magnitude of the equilibriant, it's equal to the magnitude of the resultant vector. Okay, here we go. Find the magnitude of the equilibriant of forces of 48 newtons and 60 newtons acting on point A. So we're going to start with point A. There's a force of 48 newtons here pulling, and the angle in between is 50 degrees. So I'm going to do something right here. So there's 60 newtons, and the angle in between them is 50 degrees. And I want to know, find the magnitude of the equilibriant of forces of 48 newtons and 60 newtons acting on point A if the angle between the forces is 50 degrees. Then find the angle between the equilibriant and the 48 newtons. Okay, so that's a different problem that we're going to have to talk about also. So here we go. We need to find the magnitude of this. So if I'm using my parallelogram rule, I know that this side is 60 newtons also. I know that this angle up here is 130 degrees. How do I know that? Because the consecutive angles are supplementary. And I say 180 minus 50 and I get 30. And I'm looking for the resultant vector. Okay? So I'm using what? Law of cosine. X squared equals 48 squared plus 60 squared minus 2 times 48 times 60 times cosine of 130 degrees. Okay? When we do all of that, we get a big number, 9,606 point, etc., etc., etc. That's our x squared. When we take the square root of that, we find x is, or the magnitude of x, or the magnitude of the resultant vector, is simply 98 newtons. Okay? Does that mean the equilibriant is also 98 newtons? Yes, it does. Okay? So now it's asking another question. It asked, what is the angle between the equilibrium, which is this green line, and the 48 Newton force, which is this line? It's asking, what is this angle? Okay, so to find that, we're going to have to really figure out, what is this angle? Which color have I not used? What is this angle right here? Did that resultant vector split this 50-degree angle in half? No, it didn't. So I'm going to have to figure out how I can find this. Because we know this green line going to that blue line is 180 degrees, right? So can I use what I know about triangles here to find this angle? It's not 50 degrees, okay? So I have 60 across from, we're going to put a y here. 60 over sine y, will that equal, oh, I can use 98 because I'm like, wait, I don't have that opposite, but I do have 98 opposite 130. There we go. Over sine 130. Okay. So can we find angle y? We're going to cross multiply. 60 sine 130 divided by 98 will equal sine y. Okay. And you get a decimal here that's 0.49, so sine y. Ooh, that just looks like siney. Sine y equals 0.469. Y would equal approximately 28 degrees. So here's 28 degrees. And then to get this angle on the outside, I'm going to say 180 minus 28 degrees. And we should end with 152. That is the angle between the equilibrium and the force that's 48 newtons. Okay? So we're going to have to use this law of sine, law of cosine, in with our vectors. Okay? Do we need to do another one like that? I know you're saying probably so, but you're actually saying no. But we're going to do it anyway. Find the magnitude of the equilibrium of forces of 54 newtons and 42 newtons acting on point A if the angle between the forces is 98 degrees. Okay, so I'm going to start drawing. I've got a magnitude of 54 newtons, and my angle in between is 98, so that's going to make me draw a little wider. This angle is 98 degrees. The other one was 42 newtons. So the first thing we're going to do is draw our resultant vector. Okay. We could do, I like the parallelogram. Maybe it's just because I like geometry. I know you guys are not, don't love it as much as I do. So if I say 180 minus 98, we should have something, oh my goodness, I can't do simple math in my head. 180 minus 98, and we get 82 degrees up here. Okay, can we find x? Of course we can. X squared equals 42 squared plus 54 squared minus 2 times 42 times 54 times cosine of 82 degrees. So I'm going to plug all that in. 42 squared plus 54 squared minus 2 times 42 times cosine of 82. I check, make sure I have all of the same numbers. I get something like 4048.7, etc., etc. That's my x squared. X equals the square root of that number. And I'm going to get approximately 63.6. They don't do very many decimals in here. Yeah, they don't. It's approximately 64 newtons. So that is the magnitude of my equilibrium is 64 newtons. Okay? And then they also ask, what is the angle between the force and the 42 newtons? So this time they're asking me for what is this angle, okay? So what do we have to find? This interior angle, okay? So now I know this up here is 64 newtons. I know this is 54 newtons. So I'm looking at the bottom to find this angle. I need 54 over sine. I'm just going to put a y there because I'm not that creative. That's okay. Equals 64 over, oh, this was 82. Even if I'm on the bottom, they're the same. Sine 82 degrees. I'm going to cross multiply. 54 sine 82 equals, wait, I'm going to go ahead and divide by 64, and that's going to equal my sine y. So 54 sine 82 equals that. Divided by, I'm going to go up and use the answer, 63.6, etc., etc. I get 0.84. 0.8404 something is sine y. So second sine, inverse sine, second answer is 57.18. I'm going to say my angle right here, this piece, is 57 degrees. Okay? So is that what we asked for? Is that what it wanted? No. It wants this number on the outside, so I need 180 minus that 57. And I should have 123 degrees. Okay? There we go. We are done. You can do this. All right, so let's apply this to a problem. Okay? So we're going to think about that seesaw again. There's a wagon that's going up a hill, and we don't want it to roll back down the hill. We want to keep pulling it up. Find the force required to keep a 50-pound wagon from sliding down a ramp inclined at 20 degrees to the horizontal, okay? Assuming there's no friction. So if you're in physics, there's friction always, right? So they draw it. We're going to pretend I can draw. I really can't. They're saying this is a 20-degree incline, okay? The wagon is up here. I'm just going to write the word wagon, and you're going to pretend it's there, okay? We want to know what force is going to keep this wagon from rolling down the incline, okay? So what force pulling it up is going to keep it from rolling down, okay? So this one is in your book. We're going to draw this shape, and the wagon is 50 pounds. They also talk about the force of gravity. That 50 pounds is really pulling it down. So I'm going to pretend I can draw a straight line coming straight down. There's a vector here that is 50 pounds, okay? It's pulling it down, okay? If I want to know this force, so I'm drawing this force at the top being parallel to this force that I want to know, okay? And if I connect these dots to make a right angle, okay? Because really when I drew this line, I'm going to erase just a tiny bit. This little pounds is going to be in my way. And you're just going to know that it's there. Okay? Oh, I didn't change colors. I need to change colors back to blue. Okay? So if I had drawn this triangle where this is a right angle, okay, could I make some relations about this blue triangle and this red triangle that I have? Yes. Well, if these lines are parallel, so if I have parallel lines here, then yes, I can. Okay? Well, if I know this is 90 and this is 20, I believe this angle has to be 70 degrees. Yes? It does. I promise it has to. Okay? So if these lines are parallel, I know this is 70 degrees. I know alternate interior angles have to be the same, right? So that has to be 70 degrees if I have two parallel lines. See those parallel lines cut by a transversal, alternate interior angles are congruent. Things that you can't forget. So if this is 70 degrees, what does this angle up here mean? It has to be 20 degrees. Okay? So can I use this to know? All right, they have lots of words in their explanation. I really don't care. I'm looking at a triangle where I know, I'm going to change to purple. I know I have a right triangle. I have a hypotenuse of 50, and I need an angle here. A couple of different things I could use. I could use sine, I could use cosine, I could use really anything that I wanted. I'm going to say sine 20 equals opposite, I don't know, over hypotenuse. Can I find that opposite? Yes, I can. I can say 50 times sine 20, and that will give me x, which is the what? The force I want that will keep this wagon from rolling down the hill. Okay? So 50 sine 20 is approximately 17 pounds. X is approximately 17 pounds. So I need a 17-pound force pulling that wagon or holding that wagon to keep it from rolling down the hill. Okay? That's what will help me. All right, we're going to do another one that's similar to that. A force of 16 pounds is required to hold a 40-pound lawnmower on an incline. We're on the same type shape. Okay? This time, it's a lawnmower. Okay? There's a 40-pound lawnmower. I'm just going to write mower. Okay? It's right here. And it has a 40. So I know this is 40 pounds lawnmower. And they actually tell me the amount of force it's going to take to hold it. It was 16 pounds. A 16-pound force will hold this 40-pound lawnmower without it rolling down the incline. What angle does the incline make with the horizon? They're asking for what is the angle. So I'm going to draw something as similar as I did the last time. So this force, I know I'm going to draw this parallel line to right here, and I'm going to draw my right angle. Okay? Because I know this is a right angle. I know this is 16. I also know that this angle and this angle ended up being the exact same thing. Okay? If you don't believe me, let's go back and look. If these are right angle marks, these are parallel lines, alternate interior angles must be congruent. So these two triangles, the blue and now the green, are similar, so their angles must be similar. Okay? So, we're not going to go through a whole proof of why that is, but I promise it is. So if I find this angle up here, I will know this angle that we're looking for, this question mark. They're the same. Okay? So here, this x, do I have the opposite? And I have the hypotenuse. So this time I definitely want to use sine x equals 16 over 40. So how do we solve this for x? We're going to do the inverse sine of 16 40ths. Plugging that in my calculator. I brought my calculator today, and so you don't have to see me pull it up. But then I kind of probably want to. I don't know. Let's talk about it. X is approximately, I got 23.57. Oh, that's what they get. They round it to 23.6 degrees. So they do give some decimals because that 0.5 is too far in the middle. Okay? All right. We're going to probably stop there. We're going to do one more day of 7.5. And then at the end of this week, we're going to have a little quiz over 7.4 and 7.5. Okay? All right. Until next time. See you later.